Okay, good morning, everybody. So let's talk about Amazon RDS. It's a mainly in-depth section on RDS, mainly in terms of exam and real world too. I'll try my best to explain as much the real world as possible. Okay, as an architect, what should you do, and what are all these concepts? So from exam perspective, there are a couple of things here. So what is RDS? We know it's a relational database service. It's a managed database service provided by AWS. It runs on EC2 instances, okay? But it's a managed service, meaning you will not be able to log into the underlying the virtual machine. Like how you did with your EC2 instance, you will not be able to SSH into it, okay? You cannot SSH into the underlying EC2 instance. And you never have to worry about operating system patches or anything else going on at the virtual machine level. You don't have to worry about it. That is Amazon's responsibility. And number two, even if you want to worry about it, you will not be able to. You cannot SSH into it. Why am I stressing this much on it? The reason is there will be some scenario-based questions, and he will say that, okay, you found out that there is some security concerns and with your RDS, and this is what you want to do. And one of several answers or a couple of answers could be related to you log into your underlying virtual machine and do some operating system patches or anything like that. So these will help you eliminate some of the answers. Okay, some of the red herring. So you will be able to eliminate that if you know this. So it runs on EC2, but you will never be able to SSH into it. And what are the database engines that it supports? It supports MySQL, Postgres, MariaDB, Oracle, Microsoft SQL Server, and Amazon's own database called Amazon Aurora. So Amazon Aurora internally has two flavors. It's a MySQL compliant Aurora and PostgreSQL compliant Aurora. So they have taken what Amazon Aurora is. I'll wait. We'll talk about it in a few minutes. Okay, but these are the 6 engines that that it supports. And why am I stressing it? Unfortunately, they expect you to know all 6, and it's possible to come up in the exam. I've seen it myself. So RDS is not serverless. That's another point. It runs on EC2 and it is not a serverless. Well, you will not be able to SSH into it, but under the hood, there is under the hood there is an EC2 instance, and it will automatically install one of the databases here along with the license. You don't have to worry about the license also. It's so yeah, and under the hood there is an EC2 instance, and it is not a serverless. So what it means is, in the serverless technology, you will be paying for what you use. So let's say you are reading the data from database, let's say 5 times throughout the day. You will not be paying only for those 5 minutes. Okay, you will be paying for the entire 24/7 because you are running an RDS instance there, because under the hood it's EC2 is running there. That is why I want to stress that. So it is not serverless, but only one database has a capability to be serverless in RDS. That is Amazon Aurora. So you can use Amazon Aurora as a serverless, meaning you have to configure it separately. There's no configuration actually. You can use it as a serverless. You will not be charged for the entire 24/7 based on your usage. You'll be charged. Does it make sense? Any questions there?
So, Venkat, are we basically charged for running EC2 instance behind that RDS, or are we going to charge for the storage that we used?
It's both. It's both, and we don't have to worry about how much for EC2, how much for storage, and how much for the actual, let's say, Oracle license. We don't have to worry about it. They will. Amazon RDS will provide the price for us. Okay, including the license, storage, snapshots, everything together. They will give the pricing. Does it make sense per hour?
Yes, Venkat. Yeah.
So, but my point here is, Ketan, the reason they charge it that way is because there is an EC2 instance, whether you use it or not, there is an EC2 instance running under the hood. That is why. Okay.
Yeah, Venkat. Yeah,
So Venkat,
Yes.
one quick question here. So, but still, I can still buy my own license with Oracle and I can again use my own EC2 instance to install our database, right?
Absolutely, but that is not RDS. Relational database service is a managed service where it brings its own it brings its own license. If you are bringing your own license, BY, well, bring your own license, right? So then, I mean, you don't have to tell Amazon, and Amazon doesn't have to know, and it's nothing to do with RDS. You are essentially spinning an EC2 instance. Okay, you bring your own. You install your Oracle. You apply your licenses, and you use it. So you are paying only for EC2 instance to Amazon, and you will be paying Oracle whatever the license that separately. Does it make sense?
Sure, sure.
In this scenario, we will not have any benefits of
I mean,
managed.
so the only benefit will be so few application licenses will be coming with database license, Oracle licenses. For example, SAP always, when we buy a licensing from SAP, Oracle licensing is include part of SAP product.
Yep. So I'll tell you a scenario where it happened to me only when I was working as a solution architect. My previous company, there we negotiated with Oracle. I think we had license for 10 years. So that's how we installed in Amazon. For all the newer breed, we started using RDS, but for all the older ones, we happen to have those licenses for 10 years. Okay. So we set up our own EC2 instances, installed Oracle, applied our own license. So we were paying only for EC2 in that case. Make sense? Okay. Let's go. So now, once you
so one quick question here. If I still buy go with RDS concept, right? But if I still have any issues with or say Oracle database, Oracle will still support that apart from Amazon.
So if you bring your own license, or no, you are talking about RDS, right?
I'm talking about RDS. I went with RDS.
So you have to go through Amazon support. They have their own support model. You have to go through that.
Okay, then I cannot really open anything with any ticket with Oracle.
No.
Okay.
Because it's that whole licensing model is between Amazon and Oracle, or Amazon and Microsoft for SQL Server. Okay, we are not involved there, and that's why we are paying whatever, all of that together, one single price we are paying. Okay, so now after you create the database, obviously, if you are a database administrator, you have to worry about the backup. So how frequently my data gets backed up, and also in the disaster scenarios, how quickly will I be able to recover from the disaster? Okay, so how quickly will I be able to bring my database back up in case of unfortunate scenarios? So essentially, you have to worry about backups also. So Amazon RDS, it supports two kinds of backups. One is automated backup and the other one is called database snapshots. So automated backup. So what it does is, on a nightly basis, you can specify when your database needs to be completely backed up. You can specify the window. So within that backup window, you specified the backup window. Within user specified backup window, Amazon will take the complete backup and put it in S3. After that, so let's say midnight, Amazon did the complete backup. After that, all the transactions that happen after midnight, what it does is all those commits, it will save those as a transaction in the transaction logs. So with the automated backups, the beauty is that at any point you need to, if you need to restore to any point in time, you will be able to restore within that retention period. Let's say you are keeping backup for 30 days. So within 30 days, you will be able to go back in time to any minute, any second. The way it works is that it takes a nightly full backups, and after that, it takes the transaction logs. Every single commit, it will record it. So let's say last night, 12 o'clock, I took the backup and I want to restore it. There's something happened at 8 o'clock, okay, power outage, and I want to, our availability zone down, our system down. Okay, I want to back up to 8 o'clock. I want to restore to the point of 8 a.m. this morning. So what Amazon does is, it will take the 12 o'clock backup, the complete backup, and applies all those transactions that happened between midnight and 8 a.m. and then gives you the fully full database, and you will be able to create a new database with that backup. Does it make sense? That is called automated backup. Yes, go ahead.
Okay, I understood that. Let's say midnight 12 we have backup set, and 8 in the morning the database went down and I need a backup now. So I would get a backup until midnight only. So from
no. What it does, what I'm telling you is what Amazon does under the hood. What Amazon does is, it will take the midnight full snapshot, full backup, okay? And then applies all the transactions that happened from midnight to 8 a.m. because you wanted it to be restored to 8 a.m., right?
Yes.
Okay. So from 12 a.m., at the 12 a.m., I have a full solid copy. I don't need to go back in time and then apply the transaction logs because I have the full copy at midnight. I have taken it, the full backup. And then apply all the transactions from 12 a.m. to 8 a.m. And I will give you the full-fledged database as of 8 a.m. Does it make sense?
Yeah, but how do we get from 12 midnight to 8 a.m. data?
We don't need to. What I'm saying here is that what Amazon does behind the scenes, but you don't need to. Look at it. So I'm sure everybody may have that question, and I wanted to show that anyway. See this, guys. I created this free tier database. Okay, when I created this free tier database, let's go to configuration here. No, maintenance and backups. Maintenance window is specified. Okay, so this is the maintenance window, and my automated backups enabled for 7 days. So this is my retention period. So within that 7 days, I will be able to restore to any minute, any second, up to a second level. So let's go to automated backups. Okay, I have, luckily I have an automated backup. So now go to select that automated backup that happened at 6:42 a.m. this morning. Okay, click on actions, restore to point in time. I will be able to restore to any point within the retention period. My retention period is 7 days. So it will only keep it for 7 days. Does that make sense? So now you have a couple of options here. Point in time to restore from. You can restore to latest restorable time, which is in the, it's last 5 minutes. Okay. So I can restore to 8:25. Right now it's 8:30. I can restore to 8:30, or I can specify that, something happened at 8 a.m. All of my data is corrupted after 8. So let's go back to 8. Oh, this is UTC -4, right? Okay. So let's say this is 8 a.m. and then today 8 a.m. And then you can select your DB engine, and essentially you using this backup, using this snapshot as of 8 a.m. you will be able to create a new database. And every single time when you are restoring from the automated backup, it will be a brand new database. So you will be creating a brand new database. Does that make sense?
Yes, now I
You have the data in the disk. Okay. So using the data on the disk, you are creating a brand new database as of April 25th, 8 a.m.
Hey, Venkat?
Yes.
So to understand correctly, I mean, so it is suppose with going with your example, AWS takes automated backup at 12 a.m. suppose. So and does after that basically it is keeping a log of all the transactions that happened on the database from 12 to 8 a.m. Correct?
Exactly. That is
so
why
when you want to
it is able.
Yeah.
Go ahead. Sorry.
So basically, when you want to restore at 8 a.m., basically it's restoring the database backup from 12 and then applying the logs from 12 to 8 a.m.
Exactly.
Okay. Thanks.
That's what it does behind the scenes. Okay. So within the, but as an end user, the effect for you is you will be able to go back in time within that retention period. If it's 1 week, it's 1 week. The database, the retention period can go up to 35 days. So within that 35 days, if you chose 35 days at the time of creation, then it will go up to 35 days. Within that retention period, you will be able to go back in time up to a second. That's the beauty. So 8, 10, let's say 30 seconds, I'll be able to say that. So take the data as of this, and then I'll be creating a brand new database with that. So this is how you restore it. Okay. So this is about the automated backups. The automated backups, once enabled, Amazon takes care of backing up automatically. And there is a concept of retention period. So within that retention period, you'll be able to go back. Yes.
So when you create a new database with the backup, what happens to, we'll have 2 instances at the time?
If you have the old one, yeah.
Okay.
After creating it. So you are doing this for a reason, right, Kiran? Something happened, there is a disaster happened, and then now you have the backup. Okay. So what happens most of the times is that your database is down, and then your database is down, and you have in the form of automated backups, you can go back to the latest restorable time. If you do that, right, pretty much you'll be able to go back until 8:25.
Okay.
And then you are creating a brand new database.
Okay. So the name of the instance and everything will be changed, right? At that time you need to.
Absolutely.
Everyone.
Yep.
So all the applications running using this instance will have to be pointing to the new database. Exactly.
Because this one you are taking a backup for a reason. So let's say, but I'll tell you, use case here, Kiran. So you wanted to take a production database, using the automated backups. So you wanted to take a snapshot of that and then create a new staging database or a new QA database. So that's the best way to do it. You're creating a brand new database using the production data.
Okay. It's not like in a failover situation, it's not that much helpful. It is.
I mean, in the failover situation, if you do not have a database, you are essentially bringing you're creating a brand new database. So you have the data on the disk here. Okay, you have the raw data on the disk. What do you want to do? And you want to create a brand new database. You'll be able to bring it up. Okay.
So Venkat, one quick question here.
Yes.
From an architecture standpoint, you still architect that RDS, irrespectively whether Amazon is providing or not. For example, how much memory you want or how much file system you want depends upon your database growth and everything, or Amazon automatically increase the file system storage level or anything.
Well, good question. See here, there is something called elastic. No. So where is your storage?
Yeah, I saw that. The only thing is
only storage will go like that.
Correct.
Only storage can go elastically up to a point that you specified, but your EC2 instance and all, it does not automatically scale up or down. You have to take care of it. See here, where is your EC2 instance? General purpose SSD settings. Yep. Oh, see this one, settings, you are taking it from the source DB instance. So whatever the settings that you have on the source DB instance, then you are taking it. So my point is, your CPU will not automatically scale based on your need. Your RAM will not scale automatically to your need. You have to do it. Your data will scale based on the parameters that you provided. What I'm saying here is that, let's go create a new database. Standard, let's say MySQL. Okay. So yeah, let's say production setting. DB instance, see here. If you have specified M5 X large, then you are getting a 4 virtual CPU, 16 gig RAM, and this is your EBS volume speed. Okay, 3500 Mbps, and then this is your compute, under the hood compute resource, and this is your storage. Okay, allocated storage is 100 gig, and this is where it is. Maximum storage threshold is 1000. Storage auto scaling. So it will go from 100 gig to 1000 gig. Okay, automatically you don't have to worry about it. Make sense?
So the storage allocation depends upon the maximum storage limit or storage threshold you give, right?
Right.
Yeah, but you cannot really define, what kind of storage, for example, I want my particular file system to be not more than 250 GB because I want to give absolutely, I mean, from a small databases, it doesn't really matter. For larger databases like 15 terabytes or 16 terabytes, I don't really want to give one big chunk of a data storage, from the storage standpoint.
Okay.
So I want to really limit according to application recommendations. Say that okay, the standard practice is not to give more than 2 terabyte per file system.
Yeah.
So to have maximum performance from an application.
Right.
So that you cannot do with RDS. Right?
No. I mean that's all specific, right? That's all very, very specific there, right? I mean, you have to write your own scripts and do it. But here you are talking about the complete the RDS storage here, Ravi. So this 2 terabyte is not, specific to your use case or anything, the entire database. Okay. So no, you will not be able to do that. But I'll talk about something called read replicas. Give me a minute. and see if that helps. Okay, guys. So
what is EBS? EBS, I forgot you mentioned about.
So EBS. What is EBS?
Yeah.
Anyone? What is EBS? EBS volume.
Elastic block storage.
Elastic block storage.
Yeah.
EBS volume, when we talk about EC2, remember? You have your EBS volume gets attached to that every single time you create a brand new EC2 instance. Your EBS volume attached to that.
So it says 3500 Mbps.
That's the speed at which it writes.
Speed, it writes, okay.
It's a disk speed.
Okay, got it.
Yep. Okay, so essentially you can take the automated backup. Once you enable it, Amazon automatically takes backup, and within the retention period, you'll be able to go back in time and restore your database. But when you restore it, it's creating a brand new database. That's very important for you to understand that concept also. Okay, it's because to be able to answer some of the scenario questions, and you need to know that. Restore from either of these methods. I know we only talked about automated backup. Restore from either of these methods, create a brand new database. So we talked about automated backups. Let's talk about, actually, let's reiterate some of the automated backups points. Yes.
So quick question. So, I mean, can we expect to get questions where, they will explain a scenario and then tell us, how much can you, tell us how much will the charges be? Or
no. Don't worry about that. That's insane, if Amazon ever asks. So they don't ask. Okay. So automated backups. So let's recap this one. By default, Amazon RDS creates and saves automated backups of your DB instance securely in Amazon S3 for a user-specified retention period. Okay, that's called backup retention period. You can go from 0 days to 35 days. Okay, the maximum is 35 days. Automated backup is done during user-specified window. This is called backup window. So before we go any further, I'll show you how to, what I mean here. Retention period can be configured from 0 days up to 35 days. You can restore your DB instance to any specific time during the backup retention period, creating a new DB instance. So you will be able to restore it. We just saw it. After taking nightly automated backup, it continuously saves the transaction logs to be able to restore up to second within the retention period. That's Amazon's strategy. So it takes a full backup every night and then apply the transaction logs to bring you back to any second within that retention period. So practically, what exactly do I mean by that? When you create a new database, you can be more cognizant now. Now you'll be creating it, standard create. You can do all of this with free tier, guys. So I highly recommend you do that. MySQL, you can take MySQL. You don't need production. Take a free tier. Okay, and don't worry about, okay, password. Huh? I don't need to create it. Don't worry about it. DB instance size. Yeah, simple DB instance, general purpose, 20. So there are two kinds of storage types for RDS, general purpose SSD and provisioned IOPS. Provisioned IOPS will give you a lot of IOPS, I think up to, or it starts from 6,000 IOPS. We have to see that. Okay, general purpose SSD and provisioned IOPS will give you a lot of, write speed, write performance. Okay, you'll be able to write pretty fast. So allocated storage 20 gig, storage auto scaling. We just talked about it. Availability and durability. We did not get to multi-AZ yet. We will get to that. Okay, connectivity. You know that. I'm talking about the additional connectivity configuration. Where is my? backup. Additional configuration, database options, okay, whether you want a test schema to be created, sample schema to be created or not. Okay, this is what it is, guys. Backup creates a point in time snapshot of your database, enable automatic backups. This is the checkbox I'm talking about. When you enable it, it will automatically start to take the backup. Please note that automated backups are currently supported for InnoDB. Okay, don't worry about it. So this is the backup retention period. You can go from no backup all the way until 35 days. This is the maximum retention period. Would Amazon expect you to remember this 35 days? For the exam perspective, I don't know, in all fairness, but I at least, when I took the exam, I remember this. Okay, 0 to 35 days. You can say no backup, but up to 35 days. So this is about the retention period. Now the backup window. So the backup window is select the period you want automated backups of the database to be created by Amazon RDS. If you say no preference, it will pick the time in the when almost no traffic is there, it will automatically do it. Amazon does it pretty, fairly quick, and you may have an elevated latency during this backup time. Okay, you may have an elevated latency. That is why it's good to have a multi-AZ database for your production server. So I'll talk about what multi-AZ is in a second. But you can select a window if you know your load profile, how your database load profile look like. If there are some important batch jobs that need to be run at 2 a.m. So 2 a.m. is not the good time for you. So all the important scheduled jobs will be finished by 4 a.m. Then pick up 4:05. Of course, it's the default time is UTC, but essentially you can specify within that period, take the backup. Okay.
Venkat.
Yes.
Somewhere in the FAQ, I read that, and also in the exam, I think somewhere it came. What is the default period? So 7 days was the answer. That
default is 7 days. Yes.
Yeah, that question came in one of the tests.
Wonderful. There you go. So 0, you can select 0 days, meaning it's you're opting out of the backup. Default is 7 days, 35 days is maximum. Okay. Thank you, Srinivas. Okay. Makes sense, guys? I'm creating.
So Venkat, what's the purpose of the duration there?
Oh, what's the purpose of the duration?
Because it will take whatever time it takes, right? It could. So what happens if we give the duration there?
So that's a good question. So it will do the backup only within the duration. So if it's done within half an hour, right? If you specify half an hour, then if at all your backup takes more than 30 minutes, it will actually pause and give you back the complete database without elevated latency.
Okay, so we are limiting the time.
Yep.
It should take. Okay.
Yep. Okay, that's about the automated backups, guys. I think we did pretty deep, and thank you, Srinivas, for that exam question. Appreciate that. So the default is 7 days. Maybe I should have added here as a point here. Okay. And we also looked at, after the automated backup is taken, how you can restore it. So you can easily go to the automated backup and you can restore it. And restoring is a brand new database with its own DNS name. Okay. Okay, that's about the automated backups. And the second option is database snapshots. So obviously they didn't mention they didn't mention automated here. They said database snapshots. So automated backups is an automated activity done by Amazon, and database snapshot is a user-initiated action. So it's a user-initiated backup. So at any point, so let's say for your compliance reasons or for your disaster recovery reasons, or compliance is the best example, I think. For compliance reasons, you have to be able to go back in time for for up to 6 months. Okay. And you have an automated backup in the form of 35 days. Okay. So let's say you have to have for each quarter, I'm picking up the dates here: January 1st, April, July 1st, and then October 1st. Let's say there are 4, okay? For after each quarter is finished, you want to take a snapshot of the data database and then put it out there. In case if you ever need to create a new database as of January 1st, because to earlier Kiran's question, right? So if I have an issue, but some production issue, some bothering issue in production, it's a hard nut to crack, and then we are not able to reproduce it. So maybe it could be the data. Okay, do we have so this production issue happened on January, let's say December 31st. Okay, let's put this. Can we create a brand new database using the snapshot as of January 1st? Okay, but using the automated backups, you'll only get up to 35 days. So you can take these snapshots based on your needs at your will, and those are called snapshots. It's your snapshot as of that particular date. You're the complete database snapshot as of that particular date. Okay, they're stored in S3, and you can again create a brand new instance from a database snapshot whenever you desire. So production database, you have it as of April 1st. You can, you have it stored in the snapshot, and then you'll be able to create a brand new database and, create a QA database, and then you can analyze the data, or you can analyze your particular production issue. Okay. So the database snapshot is a manual operation that you take it. So how can you take it? Well, go to database, select this one, and then you can create a snapshot, take a snapshot. And these snapshots will not be deleted until you delete them explicitly. And these will stay for as long as you want them to. Until you go and explicitly delete them, all the snapshots will stay here. Okay, I have taken this snapshot on April 20th, the weather DB. So I was planning on creating I was planning on deleting the weather database, and then right before, because I don't want to pay, continue to pay for the weather database all along. So what I did is I took a snapshot and then deleted the database. So I have the data in S3 right now. So I'll just go to snapshot and create a brand new database now. Restore snapshot, and I'll be able to go create a brand new database from this snapshot. Or I can even share this with you guys, and you will be able to create it. Does it make sense? So did I show you how to take the snapshot? Yep, actions, take a snapshot. Okay, snapshot name, test1 DB snapshot for, is it 425 today? Something like that. Yep, 425. Cannot create a snapshot because the database instance test1 is not currently in the available state. Okay, it just created, right? So you wait and then take a snapshot. And by the way,
I think it is still in a creating state on the top.
Yes. Okay. Yeah, it's still saying it's creating. So, and typically when you delete, go ahead.
Sorry, Ankit, one more question here is, when you take a snapshot, will it automatically take all best standard practices from a database standpoint? Or are we aware of that, or we just need to blindly think, okay, snapshot is taken? For example, I mean, because I work in infrastructure very well, right? So whenever someone asks us to do it, snapshots or database backups or anything, we usually keep it in a backup mode so that there is no logs writing during that state. That's what happens, and then we will take a snapshot because that's how it's supposed to take.
Right.
Does those practices followed by?
I mean, Amazon does it definitely. So, so even though I can't say it 100%, but Amazon does it. So definitely Amazon does it much better than us is what I wanted to assume it.
Okay.
Okay. So I took the snapshot name. Now I successfully created the database. Now we can go ahead and take the snapshot. So your snapshot is getting created. So, yep. As of this second, your snapshot, your complete database snapshot has been taken, and you will be able to recreate a database from that snapshot anytime in future. So 10 years down the line, you'll be able to create a database using the data that you have taken right now. Okay. So that's about go ahead.
The good thing is we can see the logs though, right? I mean, how it is creating.
Yeah. Definitely.
Venkat, can we do the automated snapshot as well, or it's not possible? Let's see, every quarter, like first of every quarter, I need a snapshot. I can define the dates, and it would automatically take the snapshot and hold it. Do you think can we do something like that or not?
You have to write your own scheduled jobs. Okay.
Oh, okay.
You have to write your own scheduled jobs and use your CLI or SDK, every single one of these actions that we did, right? Okay. You will be able to automate this.
Yeah, I saw that. Yep, I got it now. Okay. I got it. Yep.
So you can automate it with a simple code.
Yep, I got that. Yep, I got it now. There are three ways to access this. So yeah, absolutely. Yep, I got it. Yep.
Okay, guys.
Venkat, one possible question could be like when you delete the main instance, all automatic backups will be gone, but snapshots will be there.
Absolutely. Yeah. That's a very, very important, very nice way of putting it. Yes. So when you delete the database, all the automated backups are deleted, but you can take the snapshot. It's not that you will take it. Okay. Let me show you what I'm saying here is that. I'm glad you asked. So let's select this guy and then go to delete. So see, it is asking create final snapshot. Do you want to take the snapshot of the data that you have at this second? Okay, so you can do that. But if I unselect this one, then I have to acknowledge that. I acknowledge that upon instance deletion, automated backups, including system snapshots and point-in-time recovery, will no longer be available. Okay. So yes. Okay, let's move on. Let's move on with this beautiful concept called multi-AZ. So in RDS, we have this concept called multi-AZ, multiple availability zones. Okay, or they want to call it multi-AZ. So what it does is, multi-AZ is used in the case of disaster recovery. So when you create a DB instance in one availability zone, if you turn on your multi-AZ, it will create a standby instance for your primary database in a different availability zone. So there are two databases that it's creating here. With the multi-AZ option, there is a primary database. So when you create a new database here, especially take MySQL and production mode, especially production mode. Okay, let's call this guy as test2. I don't care about this admin passwords and all. So the point I wanted to show you here is that provision IOPS availability. See this one here, multi-AZ deployment. With the multi-AZ deployment, in addition to the primary database you are creating, it will create a standby database in a different availability zone. By default, your standby database is not open for you to connect. You will not be able to connect to the standby database. Never. What happens is, in certain disaster conditions, Amazon will fail over automatically. The standby becomes primary database. Amazon does it automatically. So, and all the DNS name, the DNS name will be different, but IP address, everything will be automatically mapped. So your primary DNS name does not have to be changed. So to Kiran's point earlier, by turning on this multi-AZ, you do not have to do anything. You don't have to change your DNS name. You don't have to update your code. It will automatically does a simple DNS switch, the IP address switch. Okay, and it will automatically get failed over to your standby database. And standby becomes primary, and behind the scenes, it will create one more standby database because your standby became primary in the case of failure, whether it's a disk failure, network failure, availability zone failure, your database underlying some hardware failure, any of those things happen, in those scenarios, your standby will be failed over or promoted as primary. But it is not for performance reasons. I want you to know that this is not for performance reasons. Multi-AZ is there only for the disaster recovery. So there are two databases, active standby mode. They call this active standby architecture, or there is another architecture called active. And some of these non-relational databases, it's popular in DBs like Cassandra DB and all. Active databases are popular. Active architecture is pretty popular there. But this is active standby, meaning only one database is active. The standby database is out there in a different database, so in different availability zone. So in case my primary database is down or the availability zone itself is down, then it will automatically be failed over to the standby. And you don't have to make any code changes because your DNS name will not change, nothing will change, your IP gets automatically switched. Kiran, to your question earlier, this is the answer. Okay.
Thank you.
Yep. Go ahead, Ravi.
So in the FAQ during, they also mentioned CNAME. That is the one that's going to take care.
Yep. So meaning in Route 53, you have this concept of CNAME, right?
Yeah.
So in Route 53, you have this concept of CNAME, canonical name. So you'll always be pointing to the DNS name there, but you will not be pointing to the underlying IP. That IP will not even be shown. So it will automatically switch for you. So you don't have to worry about it. Okay. So multi-AZ deployments, it creates a standby instance in different availability zone. It provides data redundancy because it's in two different databases. It's in two different databases, active and standby database, and two availability zones. eliminate IO freezes. So now, when you take the backup, nightly backup, guys, I think Ravi asked this question month and a half back. So when we talked about first time, so hey, the automated backup, during the automated backup, I do not want elevated latency. So if you have a multi-AZ architecture, if you have a multi-AZ deployment is set up for your RDS instance, so what it does is it will take the automated backup from your standby so that your active database will not be touched. So what happens behind the scenes is that you have your active database in one availability zone and you have your standby database in a different availability zone. It continuously write, synchronously write. When you make a commit here, it will synchronously write into the standby database. So that is why at any time your main database is down for whatever the reason, when failover happens, you will hardly lose any data. Within 30 seconds, it will be able to fail over and you will hardly lose any data because it's synchronously writing into standby database. So you need to understand this from exam perspective. Multi-AZ is out there only for disaster reasons, not for performance. I want you to understand that. Minimize latency spikes during system backups. Okay, because your backups are not taken from your main database, they are taken from standby database. If the primary DB instance of a multi-AZ deployment fails, Amazon RDS automatically promotes the corresponding standby database to primary and subsequently create a new standby using an IP address of the subnet in one of the other availability zones. Let's say availability zone 1 and availability zone 2. It created active in 1, standby in 2. Something happened in first availability zone. Then it will automatically promote the standby in availability zone 2 as primary, and it will create a new standby in availability zone 3, if at all, but within that subnet group. Okay? And the another point is the synchronous replication from primary to standby. It's a synchronous replication. Understand that, especially for the exam perspective. So since it's a synchronously writing it, so there won't be any lag between primary and standby. So multi-AZ is only for outages or disaster recovery based scenario questions. It is not for performance improvements. For performance improvements, there is a different concept called read replica. We'll take a look at it. But does it make sense so far? Okay. So multi-AZ failover. The primary DB instance switches over automatically to the standby if any of the following conditions occur. An availability zone outage is completely gone. The whole AZ itself is gone. Or the primary DB instance fails for some reason. Or the DB instance's server type is changed. You changed from M2 large to M4X large. At that time, it will do it. And the operating system of the DB instance is undergoing software patching. There you go. The operating system of the DB instance is undergoing software patching. When it is, if there is a planned maintenance from an Amazon perspective, it will automatically fail over. It will promote your standby database as primary, and then it will apply the operating system patches, and then it will turn back up. A manual failover of the DB instance was initiated using reboot with failover. You will be able to do that. So let's say, did you understand what I'm saying here, guys? Does it make sense? Multi-AZ?
Yeah, so we can failover if you want to.
Yes, 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 yes. So I will select multi-AZ here, but it takes time. That's the problem with the databases. It takes a lot of time. So what happens is, I'll show you. If I create this one, it's not easy, guys. So it takes a lot of time to. So you go here, actions, and reboot. It is not giving me an option here because this is not a multi-AZ database. So when I do a reboot and a multi-AZ database, okay, it will give me an option here. So it will say that reboot with failover. Then I'll be able to failover, and that's when I'm switching from this availability zone to my standby becoming active, essentially. I can do that.
So Venkat, while
Yes.
we are rebooting, only that time it could be failover, or
no. That's one of the. See here, the availability zone outage, the primary database instance fails, the DB instance's server type is changed, the operating system of the DB instance is undergoing software patching, or even network problems, any of that.
Yeah, I got that. Only thing is what I am trying to understand here is that there are 4 options. First 4 options is basically performed by Amazon. The 5th option that they give us while we are rebooting, they give us a chance to fail over. Do we have other options like when we want to fail over?
Okay.
Yeah,
you mean manually?
Yeah.
No, this is the only way.
Okay.
Yeah, this is the only way.
So once reboot is completed, again we switch back.
No.
No?
You don't need to. Why?
Oh, okay.
Because these are AB databases.
Okay.
Your active standby databases are exactly same, the exact same configuration. They have got exact same data. Everything is same.
Mm-hmm.
If you have M4X large for primary, you have same M4X large for your standby database. You have the exact same configuration. Anyone can be primary anytime.
Okay, I got it.
Does it make sense?
Yep, I got it. So once it is reboot with failover, it will continue on that until we go and initiate it again, change on that.
Yep.
Venkat, so what is that server type?
This one?
Yeah.
Where is this guy? Here, right? The DB instance server type is changed. You are changing from M4 large to M4 extra large. Meaning?
The storage.
No, that's not storage. The EC2 instance type. See here, test 1, right?
Right.
Test 1, it is.
Is that the compute?
Yep. Where is that? Where do you see that?
No.
Yeah, that's the compute. That's the compute. Yes. So.
I think the main advantage of that is when, for example, if you want to increase the resources, we cannot increase the resources directly on the existing database. We need to take a backup and increase the resources, or a snapshot and increase the resources. Correct, Venkat?
But with the multi-AZ, you have a third option, right? So see here, currently I have a DB T2 micro. Okay. So now this is not enough. So I want to change it to, let's say, R5 large. I have 2 vCPUs and 16 gig RAM. If I change this one, if I have multi-AZ, I'm changing the DB instance class here, right? The underlying, the compute resource, I'm changing it. So what it does is, it will fail over to the standby database, and standby database is becoming primary, okay, during this exercise, because there is a elevated latency, and your database may not be available for some time when you change this instance class. Okay, at that time your failover happens.
Sure.
Ravi, did I answer your question or no?
No. You answered. Okay. So, but what is the difference between this one and a read replica when you're creating a read replica?
We will talk about it.
Okay.
So that's my next topic. If everybody is clear, multi-AZ. So multi-AZ cannot be used for performance improvements. I will mention it 100 more times. This is only for failover regions. This is only for disaster recovery. This will be your very good strategy for disaster recovery. And obviously, you expect your production deployments to always be multi-AZ. Okay. So that one availability zone is down, then you have your standby copy, and standby will automatically be failed over. I want you to understand that also. You do not have to do anything. Any of these things happen here. Amazon does it automatically. So don't worry.
So Amazon supports a DR activity
in the through multi-AZ.
But still we can schedule that, right, with them. We want to test how this works. And will Amazon now we are going with,
you don't need to do that, right? You set up. So you bring down, you reboot this guy. Okay. So how will your DR? So what Ravi is asking is that I want to test my disaster recovery. Okay. What should I do? Well, you can use all these 4 items here are triggers of something out of our control, but this is in your control. So you can reboot the primary database and you can verify that your failover is automatically up. Amazon does that. So what do you do if you don't have this multi-AZ feature, right? I happen to have worked in an environment where we didn't have multi-AZ. In fact, we did not use RDS. We have used bring your own license model. Okay. So we had our own active, we have our own standby, and we used a separate software called DataGuard, Oracle DataGuard, to continuously, Oracle DataGuard does the exact same thing. It's continuously transaction logs. So every single commit happens here on the main database, it will ship the logs to the other side of the database, and that database will apply that every single commit there. So it will start shipping the transaction logs there. Okay, it does the same thing. And the standby database is never available for us to read. You'll not be able to connect to the database. It's always in replication mode. Same case here. So for our DR testing, for our disaster recovery testing, so essentially for all the architects, disaster recovery is one important concern. So, God forbid things go wrong, earthquake, lightning, or power outage, any of that, is my business impacted? As an architect, you have to be able to answer that question, right? So, and you want to schedule some DR activity. So you will do it typically, so for compliance reasons, you will do it once a year or so. So you will take a window. In that window, what you will do is you will essentially you will bring down the main database. Okay, and you will see that your standby database is picked up, and that became a primary. And then new standby got created on the other side of the, in a different availability zone. And then you bring up all the applications. In this case, your DNS name is not going to change. So your JDBC URL does not have to be changed. All the applications will magically work. So Ravi, that's how we did it. But here you do not have to work with Amazon. You can write a simple line of code to bring down your primary and then make sure that your failover comes up. Does it make sense?
Yes, Venkat. Yeah.
Whatever we typically do manually, yes, that's what you do. That's what I do. So whatever we typically do it manually, we do not have to do it with multi-AZ feature. You got it.
Can we do failover at VPC level?
Can we do failover at VPC level? Let's talk about it. So first question is, first of all, very good question. When you create your RDS database, you are creating within a single VPC. So it is only within a VPC. Within a VPC, you create something called subnet group, meaning it's multiple subnets, and they have to span at least 2 availability zones. Okay, so your primary can be in availability zone 1 and your standby can be availability zone 2. So your RDS itself cannot span multiple VPCs. It has to be within a 1 VPC. Does that make sense? And VPC is per region anyway. So you cannot span multiple regions. Only Aurora can do beyond, there is a concept called global database. Only Amazon Aurora can do using that global database concept, you will be able to have a read replica in a different region, but I'm not going there. Does it make sense? Did I guess your question properly? Or
yes. I mean, see, I mean, irrespectively, for example, I created everything in one VPC pretty much. I mean, all my databases, EC2 instances, everything pretty much. Just thinking over like VPC is one data center for me.
But understand, I will stop you there itself, guys. Correct. You all have to understand and correct me also as needed. So Ravi said one VPC, assuming that it's all in one data center. Is that right? VPC is per region, and within that we have the concept of availability zone, and each availability zone is one logical data center. So in US East 2B, Ohio, you have 3 availability zones. Your Northern Virginia, your Ashburn region, you have 6 availability zones there. That's the oldest. Does it make sense? It is not one data center. It's one VPC. You have got your own isolated network. It does not mean one data center. That's wrong. You are all over. Does it make sense? Your VPC is within a region, but within a region you have multiple availability zones, at least 3 availability zones in each.
Yes. I mean, you're right. When you say like within, so, but I can have certain databases within that VPC, correct? I mean,
absolutely.
Or EC2 instances. No, that's what my point is.
Yep.
Now, I can have multiple VPCs, or which are spread across multiple AGs, or I kind of get that, but I really want to test the whole failover of that. We cannot do that on a VPC level, right? Again,
the concept of VPC, okay, is at the region level. Within a region, we have multiple availability zones. So what you wanted to test for your DR is, think about it. Your DR use case should be, okay, if my availability zone is down, am I still in business? That is the question that you have to be able to answer. Before I speak one more sentence, is that clear, first of all?
Oh yeah, very much clear now. I mean, see, I was thinking in a typical data center standpoint, right? For example, we have almost like 3 data centers as a use case.
So that means 3 availability zones. Correct. I'm sorry for interrupting you there, but essentially that means 3 availability zones. So your question should be, if 2 of them are down, am I still in business?
Yeah. So now I was looking from a DR standpoint. So yes, for example, we do a metro cluster DR. When we say metro cluster, means there is an active sync every day happens, like pretty much. So between all 3 data centers. So when in a DR standpoint, what we do is we basically fail over the complete metro cluster. For example, the whole data center is moving to a different data center.
Okay.
Then, so whatever production systems within that data center, irrespectively, I don't really need to move manually everything. So, for example, there is you're aware in a traditional way, we do have ESXi hosts, everything.
Mm-hmm.
We can move from a host standpoint, or we can basically move the complete network from, for example, from Ashburn to Manassas.
Mm-hmm.
We have one in Mashburn, we have one in Manassas, we have one in Dundee.
Okay.
We have so we can change everything using a metro cluster concept.
Mm-hmm.
That's where I'm coming from, But my question, I got my answers.
Wonderful.
Yeah. So here you cannot really do that way. You can, it will be independent, like how your database is created, which zone it has been created. You cannot really do in that level. But does it make sense? I mean,
absolutely. So Since you brought that up to everybody, okay, just to let's take a 2 minutes break, and I'll tell you, not physical break, but I want to tell you guys a scenario. So does it make sense, first of all, what exactly we are talking about here, disaster recovery? So disaster recovery has to be one of the tools, every solutions architect should possess. So we have to be prepared for disaster, essentially, right? How much data loss and how can we simulate and all. So Netflix has this concept called Simian Army. Have you guys heard of it? Simian Army. Go read about it. Netflix is popular for that. Simian Army. So what Netflix does is they have that chaos monkeys and chaos gorillas, etc. So what they do is, so Netflix wants to answer this question. If 2 availability zones are down, oh, by the way, complete Netflix is on AWS. If you don't know, Netflix was one of the biggest, one of the earliest enterprises, went on Amazon. AWS, they've been with Amazon for more than a decade for now. Anyways, the point is that, so they will simulate the server failures. So they have these, EC2 instances. Let's say they have these EC2 instances all across the board, all across the multiple regions. So what this piece of code does is the Simian Army, they open sourced it. It's in GitHub. So what they do is, it will go randomly bring down the servers. It will just randomly delete the servers. It's kind of a terminates. It goes randomly like a crazy monkey, how it will go, and then there's no logic behind that. Pretty much it will just go randomly deletes it. Okay. Their point is that they will simulate this, I think at least once a quarter or something. They will simulate this. They will have the Simian Army go and create chaos within their infrastructure. Okay, and still they want to be able to answer this question. We are still in the business very well. So this entire availability zone is down. We are still in business. The entire, for Netflix case, the entire region is down. I think they're prepared for the entire region being down also. In fact, I was saying, when I was a solution architect for one of the automotive companies. So for us, we had to be prepared for the entire region being down. So if the complete US East region, I'm not talking about one availability zone here. We were in Northern Virginia as one region, and we were in Oregon as the second region. Even if the complete region is down, can we fail over to another region within so many minutes? We had the SLA of 5 minutes, I think. So anyways, that's the point. So you can, as a company, it should be in your strategically, your company should have this tool, and your architects should have this in their minds that we have to be prepared for it. So they will go simulate these environments. They will go simulate bringing down the availability zones. So what happens is, let's say there are six EC2 instances. They are spread across 3 availability zones. So what the script does is, it's a simple script, you and I can write, right? So what it does is, it will go and then, let's say they'll pick availability zone 1A. They will go terminate all the instances within availability zone 1A. That's what Simian Army does. Or we can write our own script to do that too. They will go terminate that, and then they continuously they test their application to see if they're still in business or any effect. So if a part of their business get impacted, you want to analyze that and then see why only one availability zone is down. That means it was not distributed properly across multiple availability zones. They'll go, we inspected it, we found out that our EC2 instances, we had this pivotal cloud foundry. So this pivotal cloud foundry, the servers were not distributed across all the availability zones properly. So we went back and fixed it. We kind of redid it. We made sure it was distributed across all of them, underlying the architecture. Okay, I just came to mind speaking of DR and such, so I thought I will share that. Okay, that's all about multi-AZ. I think we spent way too much time. Let's go to read replicas. Okay, so there is a concept of go ahead.
One last question on multi-AZ. Now let's see if primary database instance, since Ravi asked that VPC question, that's why it come in my mind. So let's say primary database instance is failed. I have created in Ohio region in Ohio region in AZ is like 2A. And I have multi-AZ, so 2A and 2B is working. I mean, 2B is already generated by Amazon when I create my multi-AZ. Now my 2A is completely gone for some reason. And Amazon is switching back to 2B. And at the same time, it is also creating another database for me. Is it using the same VPN and is it using the same IP range that I created for my private subnet?
You got it. Totally said that. You said that very, very nicely. Yes. Read this statement here. If the primary DB instance of a multi-AZ deployment fails, Amazon RDS automatically promotes the corresponding standby database to primary and subsequently create a new standby using an IP address of the subnet in one of the other availability zones.
Okay.
So it does two things there. One is it will make standby as your primary. It will promote standby as your primary. Number two, now you have your primary now, right? Because standby has been promoted as primary.
Yep.
But now we have to worry about the new standby, right? Because things could fail again in a couple of minutes.
Yes.
So it will do two things, but within the same subnet group that you created, within the IP restrictions, everything, it takes all of that into consideration and then it creates it. Okay, let's talk about this read replicas. So there is a concept of read replicas. So these are the read-only databases for your primary database. So typically, you created a MySQL database, which is available for both read and write. And now, what do you typically do? Well, all of your traffic will go to the same database for reading and writing. But let's say you want to improve the performance, or you are seeing some performance degradation because reading and writing going into the same database. So what you felt that as an architect, hey, I think it makes sense to send read traffic to a different database. Interesting thought. So sending the read traffic to a different database and then continue to send all the write traffic to the primary database. So I'm okay with a little bit of latency. But I want that scaling. I want that scalability. Okay, my one database is not able to, I know I have my multi-AZ and I have my vertical scalability, meaning I have my 4 vCPUs, 16 gig or 32 gig RAM, but it's not really helping. I have a provisioned IOPS, but still it's not helping. I want to scale it out. So in that case, the best, one of the very good options is to create an additional database and then create them as read replicas. It's a replica of the primary database, but it's only for read only. So what happens is, like in the case of multi-AZ, so your primary database is there and you create a read replica from that. So every single time a commit is made in your primary database, it will asynchronously, it's not synchronously, it's asynchronously, it will push the data into the read replicas, one or multiple read replicas asynchronously, meaning after things have happened, after commit is made here, it asynchronously pushes the data into these read replicas because they are separate databases. And all of your read traffic, you want to move the read traffic to those read replicas. By doing that, all those guys are not coming to the primary database anymore. Whoever wants to read, they're going to different databases now. They're going to different read replicas. They are like, for all practical purposes, they are exactly like database, but you can only do the read-only operations. The only downside here is that your read may not be, you may get stale data because it's asynchronous. So it may take a couple of seconds for it to happen in the read replicas. So you may get a stale data, your read people. So if I update something here in the main database and whoever is reading it may not immediately reflect that. But scaling options, it can infinitely scale because you can have as many read replicas as possible. So you want to use your read replicas for performance reasons. So let's read this one. I'll answer any questions. Read replicas are used for performance improvements. You can create read replicas from primary database. Data gets synced up asynchronously from primary to read replicas. There could be a slight lag. There could be, when you read, actually, there could be a slight lag.
So
in
this
reads.
database is...
1 second, please hold your thought. You can promote your read replica as a full-blown database also. But once you promote your full read replica as a full-blown database, so to start with, you have one primary database, and then you created a read replica. Now, at any point, you can, if you decide to convert that into a full-blown another database, because these are all individual databases, they have their own DNS names. So your code consciously goes to read. It uses read replica DNS name for all the reads, and for all the write purposes, it will go to the main database, primary database. But you can even promote read replicas as a full-blown database. In that case, the replication will be broken, obviously. Right? Automated backup must be turned on. So if you want to do this read replica, your automated backup must be turned on. Otherwise, you'll not be able to do a read replica. You can have read replicas of read replicas. Yes, you can create multi-level read replicas. Well, how can you do these read replicas? I'll come to you, Ravi, 1 second. So you have your database up and running. So this is test one is my read write database, and then go to actions. You can create a read replica. Now you're creating a brand new database here. And now I'll call this guy as, again, your read replica can be multi-AZ too. Because multi-AZ is a different concept. It's there for a different reason, right? For DR purposes. So multi-AZ deployment, no. General purpose SSD, fine. US East, blah, blah, blah. Availability zones, publicly accessible, no. Default VPC, am all fine. Enable encryption. By the way, encryption is supported by all the database engines. So I will call this guy, read replica source is test one. Sure, I'll call this test one read replica. Database ports, monitoring, log, maintenance, auto miner version upgrade. Now it will create a brand new database. Now this is my test one is, it's a primary database, and I created a read replica, test one read replica. Okay. That's how you create read replica. Go ahead, Ravi, with your question.
I think I kind of got my answer, but I'll still ask. So that means I can still create a read replica and make it a parallel production system for a reporting purpose. For example, if someone want to extract data, they can only extract data from that read replicas for the reporting, but they cannot do any writes on that system. Correct?
You answered it. I don't have to add an additional point to that. You answered it beautifully.
Okay, I mean, thank you.
Yep.
So Venkat.
Oh no worries, Ravi. It's beautiful.
Hello.
Very good questions. Yes, sir.
Yeah. Sorry, I wasn't clear. So when you create the database,
can you give me 1 minute, please?
Yeah.
1 second, guys. Okay, Srinivas, go ahead and ask me that question.
Okay, my question was, when you create a database, so doesn't it automatically create the read replicas? You have to, is it on-demand process?
That's correct.
Okay, thanks.
Because you are creating the database first and then creating the read replica. Because it's two different databases. See, this is my database. Test one is a read-write database. It's a primary database. After my primary database is created, then I went ahead and created a read replica of that. Sorry, no, not this one, but this guy. Yeah, this is a read replica. So these are two different databases for all intensive purposes. For all practical purposes, these are completely two different databases. Of course, the data gets automatically synced up. So when you write something into it, okay, on each commit, it will asynchronously replicate into this database. So you'll be able to read back here. There might be a very slight latency, but it's a great architecture to have it in our tool set, because you keep this guy only for writing or for majority of transaction processing, any of that critical stuff. You can use it for all the reporting, and for all non-critical stuff, you can read it from read replica. It's a beautiful way of separating out your traffic. And a lot of companies do this.
And from costing perspective, we need to pay for two databases, right?
Of course. Of course. These are two databases. In every single aspect, these are two completely different databases. And by the way, did I tell you that multi-AZ also two completely different databases?
Yes.
One primary, one standby. They have got exact same, replica. Okay. So what I will tell you is, without really having to create a multi-AZ, go to create database and then create the standard create MySQL and go to production. And then you can use multi-AZ here. You can check. See this one here? DB instance is $249 per month bill. And then your multi-AZ standby instance is $249. This is your primary is $249.66. And your standby is an additional $249.66 for your multi-AZ. So go up to your multi-AZ and say, do not create a standby instance. And my bill will come down to only 1 DB instance. Make sense? Okay. That's about the read replicas and in general relational database service, right? So before we conclude on the RDS piece, I'll move this guy. So we know there are 6 database engines that it supports: MySQL, Postgres, Oracle, Microsoft SQL Server, MySQL,
MariaDB.
Postgres, MariaDB, And the last one is Amazon Aurora. Thank you, Murali. MariaDB, and the last one is Amazon Aurora. So Amazon Aurora is an interesting database in a lot of aspects. So it's a go ahead.
I'm sorry, Venkat. One quick question here.
Absolutely.
So for the read replica, if you have to create in a multi-zone, multi-AZ, sorry, does the original database needs to be compatible with that? I mean, to create a read replica, or it can still be on one AZ?
Very good question. It can be one AZ, because let's talk about it. To start with, I will say I don't know the textbook answer, okay? But let's arrive at the answer. Let's see here. So you have a database. You have a database in only one AZ, okay? And you have created a read replica, let's say AZ1. You have your primary in AZ1. You created a read replica, and that happens to be in AZ1 also. That's also in AZ1. And now you created this read replica in a multi-AZ format. So you have one read database in AZ1, the second read database in AZ2. So the primary database does not have to be. What's the reason for that? I don't see a reason. So it does not have to be. Okay.
Because it is giving me an error. It says that cannot currently create a read replica to run as a multi-AZ deployment for this particular database engine, That made me think about.
Oh, that's the database engine. So let's okay, let's take a look at it. So okay, this is a test one, and then let's do a create read replica. Where is my multi-AZ?
On the top, if you go a bit down, yeah, there, yeah, you can see there. Just down to the DB2
Yeah. So let's try creating that. The parameter DB instance identifier must be provided and must not be blank. Okay. Test one read replica multi-AZ trying, right? So is it because you don't have automated backup on? Because without having the automated backup on, you will not be able to create a read replica, period. Okay, so my test1 database was not multi-AZ, but I was able to create this read replica using multi-AZ, right? You want to take a look at it, Ravi?
Yeah. Okay, Venkat, I'll
yep.
Thank you.
Yep. So out of 6 database engines, Amazon's own Aurora is one of them, and Amazon Aurora is an interesting database in a lot of aspects. So what they did is they have taken these community databases, like open source databases like Postgres and MySQL, and they made it like the commercial databases like Oracle and Microsoft SQL Server. And they re-architected, they took the source code from MySQL, it's open source databases, right? MySQL and Postgres, and they re-architected it for cloud. And then they improve the performance. I believe it's a MySQL database is 5 times more performant, I believe. We'll read it here. If not, we'll read it on the web. But it's a 5 or 10 times. It's a crazy number. It's it's that much faster. Okay, so Amazon Aurora is like a pretty much Ferrari relational database service. So in all, it's a really high performant, completely architected for cloud. Okay, and it's architected and it's built by Amazon itself. But the underlying, they have Amazon Aurora for 2 database engines, one for MySQL, the other one is for Postgres. So Amazon Aurora is a MySQL and PostgreSQL compatible relational database built for the cloud that combines the performance and availability of traditional enterprise databases like Oracle and Microsoft SQL Server with the simplicity and cost effectiveness of open source databases. It's a mix of both commercial databases and open source databases. It's really mind-boggling, and they have been pushing Amazon Aurora like anything. So that's why when you try to create your RDS instance, also the default one is Amazon Aurora. So Amazon Aurora is designed to offer greater than 99.99% availability. That's a beautiful 99.99% of availability, replicating 6 copies of your data across 3 availability zones. So it maintains 2 copies in each availability zone and at least 3 availability zones. So your data gets copied, it will maintain 2 copies in each of the 3 availability zones. So it will maintain 6 copies. Okay, and backing up of your data continuously to Amazon S3. Yep, it will continuously back up to S3. So Amazon Aurora has a second flavor. The first flavor is definitely like RDS. Okay, you can start your own Amazon Aurora, and then you can pay for the complete instance under the hood, etc. And you have a second flavor. Only Aurora has it across all the database engines. You can use Aurora serverless. With serverless, you don't have to worry about anything. You just pay as you use it, pay as you go. Pretty much whatever you are using it for, just pay for that. So use Aurora serverless if you want if you want a simple, cost-effective option for infrequent or unpredictable workloads. So if you don't know what's your database size look like, because some cases you will get 1,000 requests per minute, or 1,000 gig of write, and in some other cases we are completely idle for next 18 hours. So if you have that kind of scenario, then go for Aurora serverless. So the beauty here is that once you have your SQLs, MySQL or Postgres databases, so you will be able to create an Aurora database easily. So select your database and go to Actions and create a Aurora read replica. Rather than creating a read replica, you can directly promote this MySQL to Aurora read replica. You create an Aurora read replica. Once you get that Aurora read replica, now you can promote that read replica into full-fledged Aurora. So that's how you can have, if you have a MySQL database, that's how you can promote it to Aurora. If you're creating a brand new database, then you can create Aurora like this. So it's a standard create, or by default Amazon Aurora. So again, there are 2 flavors here. Do you want MySQL compatibility, or do you want PostgreSQL compatibility? And you can look at the version. And this is the concept I was talking about, the database location, regional or global, all the RDS databases. In fact, Dynamo also, in fact, non-relational also, it's a per region. Only this guy can go global. If you say global, what happens is it will create the read replicas in different regions. You will be able to create the read replicas in a different region, and it continuously replicate from primary database will replicate continuously into your read replicas in a different region. So let's say a lot of my customers who read continuously, they happen to be in Singapore. So I can create a global database, but a lot of my write customers, people who are writing into my application, they happen to be in the Ohio region. I can create the primary database in Ohio region by setting up the global, and then I can have a read replica set up in Singapore region. This is the only database that can support that, and it's a mind-blowing concept. That's Amazon's own Aurora database. You can play with it. Okay, and even if you look at the database features here, one writer, multiple readers, one writer and multiple readers, parallel query, you can go with the serverless. Pretty much here, a dedicated database will not be created for you. You'll be using existing ones, and you pay for whatever the usage. You specify the minimum and maximum amount of resources needed, and Aurora scales the capacity based on database load. This is a good option for intermittent or unpredictable workloads. So serverless option exists only for Aurora. By default, RDS is not serverless, guys. Okay, none of them is serverless, but you can make Aurora as serverless. Make sense? So this is an interesting database, definitely. So that's about Amazon Aurora. You can go play with it, not a big deal. And in fact, that's about all the relational databases that, the relational database concepts. Now, let's talk about the non-relational databases briefly. Amazon has this non-relational database called DynamoDB. Okay. So DynamoDB is Amazon's non-relational database. And if you guys don't know non-relational database, it's, you guys are familiar with online transaction processing and analytics processing. So you typically want to use transaction processing, OLTP, using your relational databases, meaning you want to get, when I write something and when I read back, I want to get the latest update without any latency in that. Okay, that's a typical transaction processing, and analytics is for business intelligence and all. So in the non-relational databases, it's traditionally in the relational databases, we have this table column concept. I mean, in the non-relational also, we have the table column concept, definitely, but you can store the entire document itself. So if you have a JSON, JavaScript object notation file, you can store that complete JSON into your one of the database rows as a single column. So you'll be able to store the entire document. So let's say you are storing a customer object as is. You are storing a customer JSON file as is into a customer column. Okay. Let's say you added an address details there, and zip code is not there. Now you added zip code to your JSON file. You don't have to change your database format, because as far as the database is concerned, it's just one club, like one document. Your document can grow or shrink, meaning you can add new attributes anytime, or you can remove the attributes. It's essentially, it's not strict. Okay, it's that's the NoSQL database or non-relational databases, and you have your popular non-relational databases, right? Like MongoDB, CouchDB, Cassandra, and all. Okay, and there are some key value pairs, and some of them are document based. So this is Amazon's own answer for it, and Amazon internally uses DynamoDB, the complete Amazon warehousing website they use DynamoDB internally. So very, very, very powerful, very fast, high performance. Amazon DynamoDB is a fast and flexible NoSQL database service for all applications that need consistent single-digit millisecond latency at any scale. So guys, in the exam, if you see this single-digit millisecond latency, it's DynamoDB. No database can give you that single-digit millisecond latency. 5 milliseconds, 4 milliseconds, 3 milliseconds, you know. It's flexible data model. The reason it's flexible data model is because you can dump the whole JSON into it. It's flexible data model and reliable performance make it a great fit for mobile, web, gaming, ad tech, IoT, and many other applications. Yeah, I mean, a lot of mobile, applications use it, and a lot of gaming people use it. Okay, and most of this text I got this as is from the AWS websites itself. Okay, and DynamoDB, yes, it's a serverless. Pretty much you can go create a new table there without having to worry about creating underlying database. It's serverless. So DynamoDB, it spreads across 3 geographically distinct data centers. So the data gets spread across 3 geographically distinct data centers. They don't mention availability zones. They mention the website that 3 distinct data centers, but essentially you have it. So it's a highly available and single-digit millisecond response times. That's the beauty of Amazon database. So it's not an RDS, obviously, because it's not a relational database. You have to go to services, and you have your in the database sections. See here, RDS is the first one, and then you have your DynamoDB. Okay, and from our exam perspective, we care about these 3 things: RDS, DynamoDB, and Elasticache. Okay, go to DynamoDB, and this is Amazon DynamoDB. This is what I copy pasted into PowerPoint as is. It's a fast, flexible NoSQL database service, and you can simply create tables. You can query items, monitor and manage tables. So you can create a table. Let's say I want to do a weather data. Partition key. So my primary key, let's say zip code. Use default settings, no secondary indexes, any of that. Provision capacity is set to 5 reads and 5 writes. Basic alarms with 80% upper threshold using SNS topic. Encryption at rest with default encryption type. All the, it's you don't have to worry about instances. You don't have to create the database. You don't have to worry about any of that. You can just go ahead and create it for all the practical purposes. You'll be able to do this one, without having to worry about it. You just go there, and then items are your essentially rows, and you can create it. Just you can create the complete document. You can dump everything there. Okay.
Underneath DynamoDB, is it using any other relational database, Venkat?
Okay, can you say that again?
I mean, so for us, DynamoDB is it's a non-relational database, but underneath infrastructure, is it using any relational database again?
No, it does not.
Okay.
No, it does not. Actually, it's a completely architecturally they're different, right? Because you are not strict about the data types anymore. It's pretty much the whole document can be dumped there, right? I believe Oracle 12c, starting from Oracle 12c, they started supporting these ones too.
Yeah.
And yeah, I mean, there are a couple of ways. Some non-relational databases support key value pairs. I believe Google has this concept called big table. Google's big table is a key value pair based non-relational database again. And this is Amazon DynamoDB. Okay. And actually Google Cloud Platform, they support and they advocate MongoDB quite a bit. Anyways, so it's a similar to your MongoDB, and but it's of course Mongo also is architected. It's architected for cloud. It's you can horizontally scale it. Same thing with DynamoDB. It will grow automatically. You don't have to worry about anything. You just pay for whatever the usage. Okay. I highly recommend you play with DynamoDB, and then the good combination will be, we talked about serverless, right? We talked about Lambdas, we talked about API gateway and all. So have Lambda go and fetch from DynamoDB. It's very, 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 very simple to do that. So you can write the Java code like how we did it, or you can use Node.js. Actually, Node.js connecting to relational database is pretty hard. Pretty hard meaning you have to do it pretty much on your machine and upload the code. But with connecting to DynamoDB, right, you will be able to utilize the online editor itself. It's very simple. So create a table here, dump your data, and understand how non-relational database works. Dump your JSON objects there, and how structure doesn't matter anymore. Okay. So single digit milliseconds is DynamoDB, and I told you about a silly situation there. So I got confused between this and Aurora, and I believe in the real exam when I did that 2 years back, single digit millisecond, I have used Aurora. That's wrong. So single digit millisecond, when you see that in the exam, it's a DynamoDB. Okay, so in the DynamoDB, there are two kinds of consistency models. It's not specific to DynamoDB, but in general, when you talk about non-relational databases, you will always invariably talk about the consistency models. So there's one consistency read called eventual consistent reads. Eventual consistency, meaning when you update a non-relational database, typically what happens is, by default, Amazon DynamoDB comes by default with eventual consistency, meaning if you try to read it right after, I wrote something, I updated something, when you read it, you may not be able to get it immediately. Especially within 1 second, you may not be able to get it. So it will eventually be consistent, okay, within a couple of seconds. Okay, if you don't care about a couple of seconds, then absolutely non-relational database is the way to go. Of course, with DynamoDB, you can specify it to be strongly consistent read. You can configure it to be strongly consistent reads, but the beauty and the real scale and performance, if you want to take advantage of it, go for the default eventual consistent reads. Okay. So something like Facebook, for example, right? Facebook, let's say, Srinivas, he uploaded his picture, and then he has, 20 friends. It doesn't matter really if it 2 seconds late, 3 seconds late for all the other people when he pulled up, let's say when he changes his picture, right? In Facebook, it doesn't matter. Okay, for a couple of seconds, it will show up the old picture, and then from 3rd second onwards, it will start showing up the new picture. If you don't care about it, for all those use cases, for all the lot of practical use cases, except you're talking about, stock tickers or any of your bank transactions, they can't be eventual consistent. They don't fall under eventual consistent reads. You know, you want them to happen in a single transaction, and you want to, you know, you don't want that to be committed until you know that. So when I read it, right after that, within a same second, I must get the data. In that case, then you have to go for strongly consistent reads. So when you read data from a DynamoDB table, the response might not reflect the results of a recently completed write operation. The response might include some stale data. If you repeat your read request after a short time, we are talking about short time, meaning not after minutes, seconds, after 1 second. The response should return the latest data. Strongly consistent reads. When you request a strongly consistent read, DynamoDB returns a response with the most up-to-date data, reflecting the updates from all prior write operations that were successful. So the default one is eventual consistency. Okay, and leave it that way if you really want to take advantage of all the power of DynamoDB, you know, performance, scale, and everything. I recommend leaving it that way. So that's about DynamoDB and consistency models. And we'll spend a few more minutes, and then probably I'll ask you to take a test. So the next one is Redshift. So we talked about RDS, and we talked about non-relational database, and this is Amazon's answer to data warehousing solution. Redshift is Amazon's data warehousing solution. It is for business intelligence or data warehousing. Fast and fully managed data warehouse. You just pay. Really, you don't need typically, if you want your business intelligence solutions, right? You're looking at you know, hundreds of thousands of dollars upfront before you even start writing your first query into it. Okay, but with Redshift, the beauty is you can get it going immediately. Okay, it's a fully managed data warehouse, cost effective to analyze all your data using standard SQL and existing BI tools. You will be able to analyze the petabytes of data, and then you'll be able to provide all the answers to your top level management, saying, what's my sales look like in 2019 versus the forecasted. You'll be able to do it. So as records enter the system, Amazon Redshift transparently converts the data to columnar storage for each of the columns. So this is an interesting architecture, especially from you know, Amazon Redshift. What they do is, I will rather than me trying to re-explain that, I'll show you guys. You know, AWS Redshift columnar. I like that explanation. So see here. So typically database, you know, this row will be stored like this in the database, right? It's like a as is row. It will be stored like this. So what it does is, but you're talking about, you know, you want to improve the compression. So you don't want to copy the duplicate information. Okay. And you don't want to store this row at a time. Rather, what Amazon Redshift does is they will use this columnar architecture. So this entire SSN column, they will store it somewhere. They will store this name somewhere. They will store this all the ages somewhere. They will store this addresses somewhere. They go by column by column. See here, they go by column by column. All the SSNs are stored like this. Okay, so all the names are stored in separately. All the ages are stored separately. So they store column by column. Okay, that's how they are able to shrink the petabytes of data, you know, by several folds so that you can apply your intelligent, business intelligence queries. Okay. So this is a columnar storage. So understand the Redshift is for data warehousing, and then business intelligence, obviously. And then, architecture is columnar storage. It stores column by column. Amazon Redshift achieves efficient storage and optimum query performance through a combination of massively parallel processing. Yes, it's massively parallel processing. They will spin several parallel threads and then divide the workload across all of them. And in addition to that, they also use this columnar data storage for shrinking the data. And very efficient targeted data compression encoding schemes. So because of all of that, Redshift is ideal, and you can go start Redshift pretty much, I think it starts from 25 cents per hour to, that's an average. Amazon Redshift, it's also again in the database area, RDS, Dynamo, Elasticsearch. No? Oh yeah, Redshift is here. It's a data warehousing. Amazon Redshift, you can start creating the cluster. Okay. So see this one, RA3 4x large. This is like up to 64 TB per node. And I think you will take at least 2 nodes on that. So the data is huge, massive. And take a look at the bill also here. So with this configuration, you are looking at $4,694 per month. But it's a lot cheaper compared to hundreds of thousands of dollars or millions of dollars that you need the upfront cost for any of these your data warehousing needs. I'm curious actually, if I move this to 5 nodes, then I'm talking about $11,000 per month. So please be extra careful when you create this one. Okay. But what I will tell you is, please, if you want to play with Redshift a bit, right? So do not create this. Rather, there is I came across this concept called Quick Labs. So QWIKLabs.com. Quick Labs, hands-on cloud training, or hands-on. Okay. So here they have some preset stuff. So let's search for Redshift. So nobody will teach you anything. It's just, you can come here and practice it. Advanced operations using Amazon Redshift or working with Amazon Redshift. This is a hands-on lab. So click on that, and it will have this decent look at the overview, and you can start the lab. Once you start the lab, the beauty is that they have that pre-configured system. It will come up, and then it will tell you precisely what to do. I really like it. You may want to use it for your lab, but for you guys, you did everything on your own, so you don't really need it. But something like Redshift, if you really want to get hands-on, I recommend this. I don't know if it's a free. There are some, okay, this is not free. This needs 10 credits. So 10 credits means you may have to pay a few dollars. Okay, just wanted to mention to you guys, Quick Labs. Anyways, that's about Redshift. That's all we need to know. Columnar database, and its architecture is columnar, and it's a data warehousing solution. Okay, so another database service that Amazon provides is called Elasticsearch. So Elasticsearch, it's not an RDS, it's not your non-SQL database, but it's an in-memory database, okay? For frequently accessed data, something like, let's say you are working for Amazon. And then once you log into Amazon, on the right side, you will see the top trending, last 24 hours, what are the trending products? Or when you log into YouTube, what are the trending videos, right? Let's say it gets updated every single day. Okay, you don't need to get that. Give me, so on the page loading time, when you go to Amazon.com or YouTube.com, it doesn't make sense to go to your database and say, hey, give me the top 10 trending items right now so that I will display it in my website. It doesn't make sense because they don't change that often. They change, let's say, every once a day. It does not make sense to go to this slow disk. All these databases, they rely on disk, right? So there's no point in doing that. So that's when we will use this technique called in-memory caching, right? You must be using some sort of in-memory caching. If you guys are using Java-based applications, poor man's caching is, if you don't have any solutions, at least you'll put it in your static hash map or something like that. You store some data there, okay? And that's a bad way of doing it because you have to bounce your servers to refresh the cache. But you may be using these caching mechanisms like memcached or RDS. Okay, these are popular to in-memory caching engines, memcached and RDS. So Elasticache is an abstraction on top of it. Like how RDS is abstracting out your relational databases, with simple clicks, how you are able to create your any of these relational databases. Similarly, your Elasticache is an in-memory caching service, okay, for memcached or RDS. So yeah, it's essentially when you're looking for performance, you are going for some frequently accessed data that does not change that often. You are unnecessarily going to database. Okay, what do you want to do? Well, you may be thinking about, either when you talk about the performance, you have to think about read replicas, RDS read replicas, or Elasticache. But in this particular case, my data is infrequently changed. Okay, I mean, they get changed a couple of times a day. I don't need to go to disk every single time, right? I'll rather load them into memory using one of these services here, memcached and RDS. I'll be able to refresh the cache and all. So Elasticache works with both of these engines. Okay. Yeah, it works with both of these engines. And scenario questions around performance could be either think of Elasticache or RDS read replicas. And again, ask yourself there how frequently the data is changing. If it's a frequently changed data, then go for read replica. At least you're not going to your same database, same primary database, that asynchronously copying it into a separate database called read replica, and you are going to read replica. But if it hardly changes, few times a day, then please use Elasticache, and under the hood, use either one of these two engines, memcached or RDS. So that's also in your database section here, Elasticache. So it's a web service that makes it easier to launch, manage, and scale a distributed in-memory cache in the cloud. Okay. So you can work with both of these engines. The use cases are less frequently changed data. And you want super fast performance, you are not going to disk, then you will get, of course, you will get better performance than your DynamoDB. It's a single digit milliseconds because it is in memory. I'm not making any query anywhere. I'm not going to disk to read anything. It's in memory. Okay. Okay. So that's about the complete RDS section, guys.
So one question, it is totally relevant, but I'm trying to compare what is the difference between Redshift versus data lakes.
Redshift with the S3 data lakes.
Yes.
So I recommend watching this video. So Redshift works with the traditional BI solutions. You know, if you already have your Oracle BI or something, then Redshift works like that. Your S3 data lake is you have to take your Redshift all the data into S3 data lake and do it. You will not be able to use any of your in-house, if you're bringing your own tools, right? Your Oracle BI tools and all, they don't work. And there is a small video, couple of minutes video, that talks about both Redshift. I think this one, yeah. It, watch this. Okay, so that's it, guys. So now let me stop recording, and you'll take a test. Let me stop it.
Venkat, I have a quick question.
Yeah.
That'd be pretty basic, but so I've read that for an AWS account, we can have maximum of 40 database instances, and then each instance can have, depending upon the database engine, we can have number of databases in it. So how can a database instance have more than one database in it? Is that like
good question. Well, very good question. Anybody has
schemas? You can have multiple schemas, right?
Schemas,
Exactly.
absolutely. Yep, that are your schemas only there.
Exactly. Exactly. So let me show you here. Okay.
I think Oracle is one which is limiting to one database instance only, and Microsoft, and Microsoft SQL Server is limiting to 100. Yeah. Oracle is only one, but Oracle has a different views available. You can set up the different views on one schema.
Okay.
In RDS perspective, they're not talking, on-prem.
Okay.
I wasn't thinking it's database, but schemas. It specifically mentioned that you can have any number of schemas, but then it is you can also have databases. So that's where I got confused.
I mean, you can have databases too. In our production environment, you have one instance, but we have Encore DB, like that's the main database. We can have one for warehouse, so you can split that in SQL Server.
Even on Oracle, you can still install multiple databases on one instance. You can do that.
On one instance, you can install multiple databases, and within multiple databases, you can have several schemas, right? One per user.
Yeah.
So, Sindhu, so in the case of MySQL, right? For example, MySQL, your database and schema, they both mean same. Your DB instance is different. That's your virtual machine there, right? And on top of it, you are creating, remember when you create your database, do you want me to create a default database? It is asking. It's a default schema in the case of MySQL. So traditionally, if you take out Amazon for a second completely, if you install Oracle, and then if you go to Oracle admin tools, administration, you'll be able to install multiple databases on one single instance. You'll be able to do that traditionally. These are not schemas also in the concept of Oracle database. Okay, so Oracle only supports one database per DB instance when it comes to RDS. And as you guys are saying, SQL Server supports 100.
Yeah.
So
I mean, I think the SQL Server will leverage clustering, so they can do multiple databases on one instance, I assume.
Let's ask Murali, in the case of Microsoft SQL Server, is one database mean one schema like in MySQL?
No, you can have different schemas.
So on one instance, you can create multiple databases. Once you create multiple databases, within that you can create multiple schemas.
Yes, each database can have its own schema.
I see, I see, I see. There you go. And Sindhu's original question was, how will I be able to do it? Right? So you have to use one of these, like in SQL Developer here, right? So remember when we use a SQL Developer to connect to that, after that you can do a create database.
Sure. Yeah.
I mean, in MySQL, that's how it works. So once you're logged in, I know my database is down, but once you're logged in there, you can use a create database, test, create database test. Now you created two of them. It's a two schemas in terms of MySQL, but I'm sure you'll be able to do the same thing with your Oracle or Microsoft SQL Server, etc.
Makes sense.
Very good. So does it help you now when you take the test on this topic? Because this topic, we didn't talk in depth at that time. So we created a lot of databases, a lot of RDS, and we connected it. We did a lot of stuff as a developer level, and I introduced you to RDS in the beginning. But as an architect, you'll have to understand all of these concepts, okay? Especially for the exam. Okay, so let me stop the recording here.